Hi everyone, welcome back to the session 4. In this session for ML algorithms coding, we are referring to the Alireza's blog. In the fourth session, we are going to discuss about the k-means clustering algorithm. So k-means, according to me, is one of the most easiest machine learning algorithms in which the whole point or the whole reason why we use this algorithm is to do the clustering. It's a popular unsupervised machine learning algorithm for grouping similar data points into k different clusters, and our goal is to partition a given dataset into k predefined clusters. So how does this algorithm exactly work is the k-means first work by randomly initializing k different cluster centers, one for each cluster. Then for each data point in the dataset, it calculates the distance from all the different centroids that are there, and for the one that and for the centroid that is nearest to that particular data point, that data point is assigned to that centroid. And based on that, similarly, all the data points are assigned one of the different clusters. And once all the clusters are calculated, cluster centroids are calculated, then the based on the average value of all the different data points, the new updated centroids are calculated. Once those updated centroids are calculated, then the same process repeat. It's like from each particular data point, we try to calculate which one is the nearest centroid, and then reassign those things and iterate this process until we reach a convergence point. For example, now let me try to try to make you understand through the algorithms that we have. So in this, we initialize three things like the k number of clusters, the input data set, and randomly I'll select k initial centroids. After that, once I select k initial centroids, I'll assign each data point to the nearest centroid based on the normal distance or the Euclidean distance we say. Then once I have assigned each data point to a respective cluster of these nearest centroid, I calculate the each mean of each cluster to update its centroid. And now now I'll keep on repeating and check if centroids have converged. That is, they no longer change. And once they have done, I say like I have done the clustering and I have divided this data sets into k different segments that were needed. So the coding of this thing, the implementation of k-means is also, I mean, very easy, is similar to what we just discussed right now. So in this particularly, we make a class k-means in which we say maximum iterations are 100. Then we initialize the k different clusters we want, and the number of iterations that we need. Then we define a function fit in which we assign centroids as a randomly, k different centroids randomly. And then after that, in the maximum for we are running loop for we won't go above more than maximum iterations that we have. Now we'll say to which point is assigned to which particular cluster, and then we run for each of the data point that we have. We'll run this particular loop in which we'll calculate the distance of that particular point from the different centroids, and finally I'll assign the cluster. I'll assign that particular point to the cluster that is nearest to that particular point. And then once I have run one iteration for all the data points that I had, then I'll update the cluster centroids, and then I'll say if I think I'll update it here. And then after that, I'll check for convergence if the centroid that I have and the previous centroids that I have, if those are equal, and this was not the first iteration, then if they are equal, then I'll say let's break this thing. I've got the centroids that I should have gotten. Otherwise, I'll keep on repeating this thing until I either complete the maximum iterations or I reach the convergence stage. And then finally, once this thing is done, then we assign the previous centroids as the current centroids that we have. So that for the next time when the centroids change, we can compare the centroids with the previous centroids we had. And then finally, we assign cluster assignments as our update the self variable. And then finally in predictor we are given, I think, x any 10 random data points, and then there we say like, okay, predict in, oh, so we have used predict, right, to which particular point this particular data point belongs to. Okay, finally, like once we are done, then we say like assigning each data point to the nearest centroid, in which what we are doing is for all the data points that we will try to find the different distance from the centroids, and we'll assign that particular cluster, that particular variable, that xi that we have, to the cluster in which the distance is minimum, and then return the cluster assignments to which, then I think it's a numpy array which specifies to which particular cluster this particular data point belongs to. I think this is self-explanatory. So now testing on this thing. So we have designed like decided one x1, then second x2. Then we are trying to make a numpy array from x1 and x2, where we are taking random numbers from this thing, plus 5 random numbers from this, minus 5, and then we are saying the number of k. In k means k equals to 2, and then we are fitting. Then we are seeing to which particular cluster whether one of these particular values belong to. Right, and then we print the cluster assignment, and then we print like what are the different centroids that we had. So for this, the centroids that we have is minus 5, minus 5.13, and the second centroid we have is 4.46, 5.04. And if we try to visualize what has happened is, this thing is like we have plotted this thing using matplotlib. So I think that was a very easy understanding of k-means clustering. However, how can we, there are certain ways how we can optimize this thing. So first thing is like a random initialization of centroids. Instead of initializing the centroids using the first k data points, we can randomly initialize them to improve the convergence of the algorithm. And this can be done by selecting any k random data points of the input dataset as the initial centroids. Earlier stopping. We can stop k-means algorithm if the cluster assignments and centroids do not change after certain number of iterations. This helps us avoid unnecessary computations if we are getting the same output every time. And the third is like using vectorization. We were earlier using numpy arrays. How numpy arrays and going looping through each of the variables. However, we can use vectorized operations to speed up the computation, to avoid the need for loops and make the code more efficient. And so if we try to apply those things into the code that we had earlier is like, I think we have defined this particular parameter tall. So, and I think this is like what we are doing is we are trying to pass everything as a vectors. We are using vectors everywhere, and then update the centroids based on, right. And for convergence, we are saying like if the difference between the past centroids and the current centroids is less than 10 is power minus 4, then we say it's an early stopping. Mhm. So yeah, that's it for the k-means clustering. This was a very easy topic. In case if you have any doubts or feedback, please let me know in comments, and we'll see you in the next upcoming session. Thank you for joining.